Welcome back to Trillion Engineering Solution. Please don't forget to like and subscribe to our channel. So guys, today we'll be talking about electric field. But first of all, what is a field? So a field is a region of space under the influence of some physical agents or forces. Now, what is an electric field? If a field is a region of space under the influence of some physical forces or agents, then an electric field is a region of space where charged bodies experiences electric forces. The electric field is just a way to describe the action of a charge upon another charge at a distance. In essence, is it pulling or pushing the other charge towards or away from it? This is just to show the effect of a charge upon another charge or a charge body upon another charge body. And such field is being known as force field, and it is represented by the electric line of force. Since force is a vector quantity, and we all know that vector quantities are quantities that have both magnitude and direction. Therefore, we can say that the electric force field has both magnitude and direction, since it is also a vector quantity. Now I'm showing down here is the magnitude and the mass of these charges. Now the magnitude of these charges, both positive and negative, are the same. And this is equal to 1.602 times 10 to the power of minus 19 coulomb. Why the masses are different? Now the mass of a negative charge is 9.11 times 10 to the power of minus 31 kilogram, and that of the positive charge is 1.67 times 10 to the power of minus 27. This is a simple diagram trying to describe the electric field. Up here is a body with positive charge, and beneath is a body with negative charge. Now the space in between is what we refer to as the electric field, because this is where the action is being taken or felt. Now we can see the lines showing the direction of this effect of force. This is what is known as the electric line of forces. And this effect is being directed from the positive down to the negative. Why is this so? Why is there no line going from the negative down to the positive? This is because the direction of an electric field at any point is given by the direction of a force acting on a small positive charge at that point. And the line of force starts only from the positive and ends only at the negative. Therefore, there can be no flow from the negative down to the positive. If so, it is useless. Talking about the electric line of forces. The electric line of force is an imaginary line drawn at a point in the electric field so that the direction at any point gives the direction of the electric field at that point. It cannot be seen, but it is drawn to show or illustrate the direction of the electric field. Now the property of this field: 1. The line of force starts only at the positive and ends only at the negative. The line of force do not intercept with each other. In a uniform field, the line of force is straight, parallel, and uniformly separated. The line of force shows the direction of the electric field. And lastly, the line of force are continuous in any region with free charges. These are the properties of the electric line of forces. There is just no way we talk about electric field I won't refer to one of the most important laws governing the electric field, which is the Coulombs Law. The Coulombs Law states that if two charged bodies, Q1 and Q2, are separated by a distance r, the force of attraction or repulsion between them is directly proportional to the product and inversely proportional to the square of their distance apart. Showing from this image, this is the mathematical representation of the Coulombs law, where F is equals to K Q1 Q2 all over R square. Now the K is a constant, while Q1 and Q2 are the charges from the charged bodies. The R is the distance apart. Now let us work on this example. The electron and proton of hydrogen atom are separated by a distance approximately 5.3 times 10 to the power of minus 11 meter. Find the magnitude of the electric force and the gravitational force between the two particles. What is the ratio between the electric force and the magnitude force? Here we are asked to find three things: the force of magnitude, the force of gravity, and then to compare the both forces, take their ratio, and show this. So guys, the first thing we're going to do is to bring out our values. Now, our magnitude. Now for our negative charge is 1.602 times 10 to the power of minus 19, and that of our positive charge is same because the magnitude of both positive and negative charges are equal. Now we have our constant K, which is equal to 9 times 10 to the power of 9, and our distance apart, which was given to be 5.3 times 10 to the power of minus 11. Now, we know our formula for the force is F is equals to K Q1 Q2 all over R squared. Imputing all this into this formula, we're going to have our force to be equals to K, which is 9 times 10 to the power of 9 times Q1 1.602 times 10 to the power of minus 19 times Q2 1.602 times 10 to the power of minus 19 all over the square of our distance apart, which is 5.3 times 10 to the power of minus 11 squared. F will be equal to 2.309 times 10 to the power of minus 28 over 2.809 times 10 to the power of minus 21. Now our force is going to be equals to 8.2 times 10 to the power of minus 8 Newton. This becomes the answer for our force of magnitude. So guys, don't forget to also ask to find our force of gravity. Force of gravity. Now our force of gravity is equals to G ME MP all over R squared. Now where our G is our universal gravity, which is equal to 6.67 times 10 to the power of minus 11. Now our ME is the mass of the electron, which is equal to 9.11 times 10 to the power of minus 31. And our MP to be the mass of our proton, and this is equal to 1.67 times 10 to the power of minus 27. Our distance apart, which we already know R, to be 5.3 times 10 to the power of minus 11. Now imputing this into this formula to find our gravitational force, Fg is going to be 6.67 times 10 to the power of minus 11 times 9.11 times 10 to the power of minus 31 times 1.67 times 10 to the power of minus 27, all over the square of our distance apart. And our Fg, after imputing this, is going to give us 3.6 times 10 to the power of minus 47 Newton. This becomes the answer for our gravitational force. Lastly, we are also asked to find the ratio between our force of magnitude and our force of gravity. And our force of magnitude, which we got to be 8.2 times 10 to the power of minus 8, all over our force of gravity, which is 3.6 times 10 to the power of minus 47. And our ratio becomes 2.27 times 10 to the power of 39. This becomes the answer. Thanks guys. Hope you found the tutorial helpful and interesting. Please don't forget to like and subscribe to our channel.